understood the limits and differentiation, then only you can able to go through the integration. After knowing differentiation and integration, you are definitely very clearly understood the differential calculations. So, based on that, we will discuss the main chapter called calculus. What is calculus? So, it is a Greek word. In villages, the small kids, they play with stones, small stones they will take for counting. For counting them means the stone, it is used for calculation. It is the actual meaning of calculus. Dear students, calculus is nothing but calculations. What is calculation? We know that calculation is nothing but addition, subtraction, multiplication, division of numbers. Here in calculus we do the same procedure, but we will take the very smaller values for addition, subtraction, multiplication and division. So, calculus is a branch of mathematics which deals with the study of calculations of infinitesimally small values. That means, infinity means it is very smaller value or very higher value. Infinitesimally small means it is 0.00001 or 0.00002 like that. So, that is the meaning of calculus. So, calculus is a branch of mathematics which deals with the study of calculations of very smaller values, that is infinitesimally small values. So, this calculus was developed during 16th and 17th century. So, behind this calculus development, the main mathematicians are Leibniz and the great physicist Einstein and Newton. After that, there are many scientists, mathematicians involved in developments of the calculus. So, this is the background of calculus. So, in the calculus, the first chapter is limits. What is the limit and how it will be related or how it will be applied for calculus, that will be study onwards. So, to understand the limit, we should aware of certain quantities, certain definitions, certain basic ideas. What is that? The basic idea required here is some quantities, constants and variables. We should know the definitions of constants and variables. Dear viewers, the literature meaning of constant is what? It is unchangeable. That means any quantity which can take or have only one value under mathematical calculations or investigations, that is said to be constant. So, I will repeat it. Constant is a quantity which is unchangeable, which cannot be changed, under any mathematical investigation, is known as constant. You take example for constant. So, boiling point of water. So, it is a fixed value. It is boiling point of water is 100 degree Celsius. It is 100 degree Celsius. The distance between two milestones on a road. The distance between two milestones on a road, it is also a fixed distance. Then it can also be called as constant. So, in case of calculations like circle area. So, we use the formula, that is area is equal to pi r square. Pi is nothing but a numerical value, it is also a constant. So, constants are nothing but the quantity which can take only the one value. Under any mathematical investigation, they are called as constant. Next, let us see the definition of variable. So, variable, it is a varying in its value, it takes different values in the same mathematical investigation or mathematical calculation, that is called as the variable. It can take different values under the same mathematical calculations, that is said to be variable. You take an example, y is equal to 3x plus 1. In this example, y and x, they are the variables. If you take certain values of x, that will be change in the value of y. So, as we take, for example, x is equal to 1. So, y is equal to 3x plus 1. If I take x is equal to 1, y become 1 into 3, 4, 4 plus 1 is equal to 5. If I take x is equal to 2, 2 into 3, 6, 6 plus 1 is y, 6 plus 1 is 7, that will be the y value. So, I did the same type of mathematical calculation, but for different values of x, we are getting different values of y. That means, under same mathematical calculation, we have a different values of x as well as y. Therefore, we say that x and y are said to be variables. In the formula area is equal to pi r square. Here a is one quantity, r is another quantity, variable quantities. This pi is a constant. If I change the values of r, there will be a change in area. As the circle radius increases, its area also increases. Therefore, as r changes, the area also changes. Hence, we can say that area as well as radius both are variable. Like that, we can quote many examples. Let us take the variables are two types. They are dependent variable, other one is independent variable. Friends, dependent means what? So, it is nothing but depends on another. Independent means it does not depend on any of the other thing. So, that is the meaning of dependent and independent. So, dependent dependent quantity and independent quantity, dependent variable and independent variable. In the example, y is equal to 3x plus 1. As x changes, then only there is a change in y. Therefore, we say that when there is a change in x that leads to change in y, it means x value is independent, y value is dependent on x. That is why we say that x is independent variable, y is dependent variable. So, got it. So, x is a independent variable because it does not depend on y, but y is a dependent variable, it depends on x only. So, therefore, they are the types of variables. Using constant variables, we can define another important thing is function. Function, generally in our houses we will have a sort of function, maybe a marriage function, it may be a naming ceremony, or it may be some other type of function. Why it is said to be called as a function? So, function involves many events which depends on different events. So, many events will be included in a function. In mathematics also, the function gives the same meaning. So, function here it depends on constants, variables, and they are related to each other. See, the function is defined as the two variables are connected by a relation. So, this relation is connection in between x variable, y variable and the constant, that is said to be a function. So, function is a relation which involves variables and constants. So, I will show the examples. See, y is equal to 3x square, 4x plus 3. Here y is a function of x. So, y depends on x, that is why we call it as y is a function of x. Usually we will write a function in this way, y is equal to f of x, h is equal to f of t, z is equal to pi of theta. So, we will denote like this, a function will be denoted like this. See the second example, y is equal to 3 sin theta plus 2. See, constants are there, theta is a variable. So, this is y also variable, theta is independent variable, y is dependent variable, the numbers are the constants, all are connected in a relation. What is that relation? That relation is y is equal to 3 sin theta plus 2. You take the third example, area of a circle. So, the area of a circle we will write like this, area is equal to pi r square, area is equal to pi r square. So, pi is constant, r is a radius, a is area. As I told earlier, in any circle the area depends on the radius. As the radius increases, automatically its area also increases. As the radius increases, its area also increases. R is independent variable, a is dependent variable, pi is constant. All these are related in some relation. What is that relation? A is equal to pi r square. So, it is a function. It is denoted like this, a is a function, a is a function of r. Let us discuss different types of functions. Let us discuss the different types of functions. As I mentioned here, the different types of functions are trigonometric functions, algebraic functions, single and many valued functions, linear functions. There are different types of functions given here: quadratic function, polynomial function, rational and irrational function, explicit and implicit function, odd and even function, defined and undefined function, inverse function, logarithmic function, composite function, parametric function, etc. We can quote some other also. So, we discuss a few of them. Trigonometric function. What is trigonometric function? Trigonometric function is a function which involves the trigonometric functions like sin theta, sin function, cos function, tan function. If any function involves trigonometric ratios, it is said to be a trigonometric function. See, y is equal to 3 plus 4 cos theta. It is a trigonometric function. You see this example, this can be said to be a trigonometric function. What is algebraic function? Algebraic function. So, algebraic function is a function which involves algebraic terms. So, what are the algebraic terms? Maybe a, b, c, d, x, y, z, like that. So, algebraic functions, this is an algebraic function. Y is equal to 2x square minus 4x plus 3, it is a algebraic function. Single valued and many valued function is important. Single valued or many valued functions are nothing but, if I take a function y is equal to 3x plus 1, if I change x value, x is equal to 1, you will get y is equal to 3 into 1, 3 plus 1, 4. For one value of x, we got one value of y, it is unique. If I change the value of x, then y changes. For x is equal to 2, y become 2 into 3, 6, 6 plus 1 is 7. So, for every one value of x, you will get one value of y. That means, it is a single valued function. What is meaning of the many valued function? The many valued function is nothing but, if you take the value for independent variable, you will get more than one value of dependent variable. Got it? Suppose if I take y is equal to x square. So, it is a algebraic function. For x is equal to, for x y is equal to, if I take y is equal to root x, y is equal to root x. For x is equal to 1, x is equal to 1, you will get two values of y. That is, for every one value of independent variable, if you get more than one value of dependent variables, such functions are said to be many valued functions. Linear function, so its degree polynomial is 1, linear. So, y is equal to 5x plus 1. So, x independent variable whose power is equal to 1, that is the meaning of linear function. Next, quadratic. So, its degree of polynomial will be 3. Polynomial, the function n power is equal to n, rational and irrational function, implicit, explicit, odd and even multiple, odd and even functions. So, odd, you take odd function and even function. So, what is meaning of odd function and even function? So, for odd function, say y is equal to f of x, y is equal to f of x, or this is what it is a function of x. If function f of minus x is equal to f of x, if f of x, f of minus x, f of minus x is equal to f of x, then it is said to be even function. So, what is even function? For any function, if I replace x as minus x, if you get f of x, that is said to be even function. Suppose if f of minus x is equal to minus f of x, that is said to be a odd function. F of minus x is equal to f of x, then it is said to be even function. F of minus x is equal to minus f of x, it is said to be odd function. So, logarithmic function, it includes logarithmic term, composite function or function of a function, parametric function. So, all these functions will be discussed later on. So, as I told earlier, the odd function and even function, see, you take the example for even function, f of minus x is equal to minus f of x, that is said to be odd, f of minus x is equal to f of x, it is said to be even function. I have given few examples also. Some functions are neither be odd function nor be even function. So, I have given example x square plus 7x plus 3. So, if you take x is equal to minus x, then either it will not become a whole thing minus f of x or f of x, then it is said to be neither a odd function nor a even function. Next, very important, it will give the connection to the definition of limit, defined and undefined function. Defined means what? It is having some definition. Undefined, it is having no definition, that is the literature meaning. A function f of x, a function f of x is said to be defined function at x is equal to a if f of a is defined. So, I give you one example, y is equal to 3x minus 1. If I put x is equal to 3, if I put x is equal to 3, then y become 3 into 3, 9, 9 minus 1 is 8. It is having a definite meaning, means for every value of x there will be a y value, at every value of a you will have a definite value, then it is called as meaningful value, or it is having some part of meaning or values. You take another function f of x which is said to be undefined, that means at x is equal to a, f of a is undefined or obtained in any of the following forms. The forms are infinity, 0 into infinity, 0 by 0, infinity by infinity, infinity into infinity, infinity minus infinity, 0 to the power of 0, infinity to the power of 0, 0 to the power of infinity, 1 to the power of infinity, like that. They are all called undefined form. So, defined means for every independent variable you have a value of definite variable, that is meaningful. If you do not get any value for y at x is equal to certain value, it is said to be meaningless, it is having no meaning. See, a function is said to be undefined. So, at f of a is equal to it may be infinity. I told in the next slide, I shown it. See, infinity, infinity into 0, or they are all undefined forms. The important thing is the limit of a function. Let us consider a function y is equal to x square minus 1 divided by x minus 1. So, this function, let us check whether it is a meaningful function or meaningless function. It is defined or undefined. You take the value of x is equal to 1. The value of x is equal to 1, it implies that 1 square is equal to 1, 1 minus 1 is equal to 0 divided by 1 minus 1 is equal to 0. So, 0 by 0, is there any meaning? For 0 you will have a meaning, for 0 by 0 you do not have any meaning. Hence, this function is undefined at x is equal to 1. The function y is equal to x square minus 1 divided by x minus 1 is a undefined at x is equal to 1. It is a undefined, no doubt, but we can have a certain meaning for this function. So, that will be explained in the limit concept. See, however, we can calculate y for different values of x very closer to 2, very closer to 2. See here, if I take x is equal to 0.9, x is equal to 0.9, you will get y value is equal to 1.9, but x value is 0.9 square minus 1 divided by 0.9 minus 1, which gives you 1.9. If take x is equal to 0.95, then you will have y value 1.95. If you take y value is equal to 0.99, for y value you will get 1.99. For x value 0.9995, you will get y value 1.995. For x value 0.999, you will get y is equal to 1.999. Like that, if you increase the value of x till what? Nearer to 1, but not exactly 1. See, 0.9999 is very close to 1. Similarly, 1.001 is also very close to 1. For these values of x nearer to 1, for that y will be defined. So, see the y values at close to 1, 1.999, and here 2.001, except at x is equal to 1, this function is having a meaning. So, therefore, it is having a limit. You observe this Observe the table. As we are increasing the x values, y also increases. As the x approaches to 1, as the x approaches to 1, the y approaches to 2. That is the meaning of a limit. X approaches to 1, y approaches to 2, and we may say that although y is undefined when x is equal to 1, but there is a limit exists. So, that limit is taken in this form. Limit of, this is read like this, limit of this function. Limit of this function is x square minus 1 divided by x minus 1. As x is nearer to 1, is equal to 2. What is limit of a function? The limit of a function is defined like this. A function f of x is said to tends to the limit L as x, tends to a. This is a limit. As x tends to a, if the difference between f of x means this is f of x, and L remains as small as we please, so long as x remains closer to a. So, its meaning is simple. The difference between x value, and 1. If I take 0.9 and y, this is constant, then the difference between L and function f of x and 2, for 0.9, here we are getting 1.9. So, this is 2. What is the difference? The difference between these two is 0.1. What is the difference between these two? Again this is 0.1. So, this difference between these two, always difference between these two, that is the definition of a limit. A function f of x is said to tends to the limit L as x tends to a, if the difference between f of x and L remains as small as possible, such that x is very close to a. This is x, this is a, this is L, this is function. This is the meaning of definition of a limit. That means simply we can say like that, for anything there will be a limit under certain condition, even though it is undefined at some value, but it is defined at very close to that particular value. You check this function here. For the function y is equal to x square minus 1 divided by x minus 1, it is undefined at x is equal to 1. Instead of taking x is equal to 1, if you take x close to 1, there will be a value for y. That is the definition of a limit. So, mathematically it is written like this: limit of function as x tends to 1 is equal to 2. See, next we have a properties of limits. You take f of x and g of x are the two real variable functions, they are in x. If I take the limit like this, limit x tends to a, f of x is equal to p. and limit x tends to a, g of x is equal to q. Limit of function as x tends to a is equal to p, limit of function g of x as x tends to a is equal to q, where p and q are finite quantities, where p and q are the finite quantities. You see the first property, limit as x tends to a, f of x plus or minus g of x. The functions are sum or difference of the two functions. The same limit can be extended for both the limit. See, limit as x tends to f of x as x tends to a plus or minus limit as x tends to a of g of x. So, whose answer is equal to what? Limit of function f of x is p, limit of function g of x is equal to q, that is p plus q. You take the second property. The second property is limit as x tends to a, f of x into g of x, product of the two functions. Product of the two functions, here also we extend the same limit for the both the functions. As a limit x tends to a, f of x into limit x tends to a, g of x. The value for this is equal to p, the value for this is equal to q. This is p into q. Next property, quotient of the two functions. Limit, common limit for the quotient of the two functions. Limit of f of x divided by g of x as x tends to a is equal to, the same limit can be extended for f of x and g of x for quotient also. Say, limit of f of x as x tends to a is equal to p, limit as g of x as x tends to a is equal to q. So, answer is p divided by q. See the fourth property. So, this fourth property gives you that a function is producted with a constant. Limit of a function along with producted with constant k into f of x. Here we have to take k constant outside the limit, then it is equal to k is equal to what? We can take constant k into limit of f of x as x tends to a, that is k into, for this limit is equal to p. It is assumed value, this limit is equal to p. You take any constant k, you take any limit, so its value will not be changed, it is unchanged. Limit of k is equal to k only for any x tends to any value. See the sixth one, we have taken log of function. Log of function, for log of function as x tends to a, whose limit value is equal to, we can take like this, log of limit of function as x tends to a. Log is taken outside the limit and limit is applied only for the variable, that is function. Finally, you will get log p. Next, seventh one, nth root of f of x. If any function is taken under a root, say root of nth root of f of x as limit x tends to a, whose value is, limit can be extended for the only function under root or nth root, it is taken constant, that is nth root of p. Let us discuss a few problems based on the limit. We have different methods of limit and we can work out problems on all the different methods. The first method which is direct method. So, in direct method what we will do? We will take the limit and we will directly substitute into the given function and we will arrive the value, whether we will get finite value or infinite value, whether we will get defined value or undefined value. So, that is the direct method. You see the example, limit of 3x square minus 4x plus 7 as x tends to 2. As I said, you take the value x is equal to 2 directly. So, here tends to arrow indicates tends to means nearer to, close to, very close to 2. So, x square 3 into x square minus 4 into x value is how much? It is 2 plus 7, 2 square is 4, 4 into 3 is 12, minus 4 into 2 8 plus 7, 12 minus 8 plus 7, it is 12 plus 7 is 19, 19 minus 8 which is equal to 11. It is having a meaningful function. For x is equal to 2, the function whose limit is equal to 11. You take the second example, limit of 9x square minus 5x plus 4 divided by x minus 2 as x tends to 2. Here in place of x, what we have to substitute? We need to substitute x value is equal to 0 directly. X square 0 square is what? 0 only, 0 into anything is 0, 5 into 0 plus 4 divided by 0 minus 2. This is 0, this is 0, remaining is 4 divided by minus 2, 2 ones are 2, 2s are, you will get minus 2. So, here also this function is having the limit of minus 2 when x is nearer to 0 or x tends to 0. You take the third example. So, in direct method we use direct values. X tends to pi, 4 minus 3 sin x divided by 2 plus cos x. X is equal to what? X is equal to 0. 4 minus 3 sin pi 2 plus cos pi. You take cos pi value is always minus 1, sin pi value is equal to 0. So, dear students, please remember what we have studied in first semester, the topic like trigonometry. The trigonometry plays very important role in understanding this calculus. So, that is why I am requesting you to have a formula, have the trigonometric values for standard angles, and you have to be remember all those things which will very much helpful in understanding the calculus. See the example, we need trigonometric ratios for certain values, that is cos 180, cos 180 is equal to minus 1, sin 180 is equal to 0. Such type of trigonometric formula needs for understanding the calculus, they are very much useful. That is why you go through all the trigonometric formulas. This is 0, this whole thing becomes 0, this is minus 1, 2, minus 1 is equal to 1, 4 minus 0 is equal to 4, finally the limit of the function is 4. You see the next one, fourth one, limit 7 minus 3 e to the power of x divided by 2 plus 3x. Here x value we need to take 0, e to the power of 0, anything to the power of 0 is always 1 except 0 to the power of 0 is not equal to 1. E to the power of 0 is 1, that is 7 minus 3, 3x, 3 into 0, that is 0, 2 plus 0, this is 2, 7 minus 3, because e to the power of 0 is equal to 1. 7 minus 3 is 4, 4 by 2, 4 by 2 is always 2. These are few problems based on direct method. So, dear friends, today we discussed what are the definitions of constants, variables, functions, and we learned what are the different types of functions are there, and the definition of limit also we learnt. So, I just recall some of the definitions. Constant, what is constant? It is a quantity which cannot be varied its value under any type of mathematical calculations. Variable, so variable is a quantity which can take different values under same type of mathematical investigations, that is called variable. So, constant and variable are very relatively related to express some function. So, function is a relation which is connected with the variables and the constants. So, we have a function meaning relations between constants and variable, that is the meaning of function. What are the different types of functions we learned? We learned algebraic function, trigonometric function, exponential function, and the implicit function, explicit function, parametric function, logarithmic function, etc. So, in constants we have the different types of constants. One is absolute constant, other one is arbitrary constant. Absolute, all numerical constants are the absolute constants because their values are fixed. In absolute constants, pi value. So, pi value is always 22 by 7, that is 3.142 something, it is fixed value. Therefore, it is a absolute constant. Then there is another type of constant which is arbitrary constant. So, arbitrary means it can take the different values for the in place of constant under different conditions. For example, if I take the function like this, y is equal to 3x plus 2, 3x plus 2. So, 3 is constant, 2 is constant, they are the absolute constant. Suppose if take y is equal to mx plus c. So, m is a constant, c is also a constant. Here 3 is there in place of m, 2 is there in place of c. Here the values are fixed, their value cannot be altered, changed, but here m is constant, c is constant, their values are different under different situation. For some, so it is a equation of line, y is equal to mx is equation of line, m is slope, c is intercept. As the line changes, the value of m and c also changes. So, m and c are said to be arbitrary constant, arbitrary constant. So, arbitrary constants are nothing but parameters. So, they can take the different values. I tell you another simple example, distance between two places, distance between two places A, B is equal to m kilometer. So, what is m? As the place changes, m also changes. So, m can take different values under different conditions. That is why I told m is a arbitrary constant. M is a arbitrary constant. If distance, if I say distance between Mysore and Bengaluru, then I should clearly say that it is 150 kilometer. So, this value is not altered, it cannot be changed, this is a absolute constant. In place of 50 and in place of places, if I take some two places, if I mention A and B and whose distance is equal to m, that means m will become arbitrary function, and if I take the numerical value, then it will become a absolute constant. Dear viewers, today we discussed basic definitions of the basic definitions, the related ideas which are helpful for understanding limit. So, this limit is very important in understanding next topic called differentiation, and in this chapter we concluded the direct method problems. Next class we will discuss the other methods in finding the limit of a function. Thank you very much.
Good morning everybody. Today we shall discuss the